Hello, welcome again to Block 2, Use of Algebraic Notation, Lesson 6. I'll share my screen. So, in your previous lesson, you learned how to find the function machines when you were given, single function machines when you were given the expressions of the input and the output. In today's lesson, you're going to learn how to substitute into single algebraic expressions. But before we start, I would like you to do this retrieval practice for 3 minutes. You can pause the video and do the retrieval practice for either 2 or 3 minutes. Well, I'm going to assume you've paused the video and you've worked through, you've really thought about the retrieval practice, which helps you think about your previous learning. So here are the answers. So here we're asked what the expressions mean. So explain what the expressions mean. So 5t means 5 times t, or 5 multiplied by t. 5 plus t is simply 5 add t. T subtract 5 means subtract 5 from t. Another way of saying it is t minus 5. T over 5 here means t divided by 5. And then 5 over t means 5 divided by t. It is really important for you to remember that from our previous lesson, we learned that multiplication and addition are commutative. Don't forget that word, commutative, meaning the order in which we use the operations do not matter. So for example, this here can be written as t plus 5. We'll get the same result. And then 5t is the same thing as t 5. Okay? But division and subtraction are not commutative. We're going to see more of that in this lesson. And then here we're asked, question 2, is there more than one answer for each expression? Of course, we can get more than one answer, especially when we think that division and subtraction are not commutative. Okay, let's do some new learning. If I ask you to substitute b equal to 6 into this expression, of course, we can write it 5b as a bar model. Okay, so remember our first bar model which we learned, the bars are always added. Okay, so 5b is 5 little bars, 5 lots of b. So if we substitute the 6 in place of the b, because substitute means replace b with 6, you would have this. So actually, it is 30. So it's like saying 5 lots of 6. If I say you should do 5 plus b, of course, if we represent this as a bar, remember we always add the bars, we'll have 5 and then a bar for b. So if we substitute b with 6, then if we add the bars, we'll see that our answer is 11. Here, if I ask you to substitute b with 6 for b for the expression b minus 5, if you draw the bar, you can just have a bar for b, and then subtract 5 means you need to take away 5 from whatever b is. Of course, b in this instance is 6, so your answer will be 1. Okay? What about this one? If we're asked to substitute y equals 10 into the expression y divided by 5, of course, we can draw our bar to say, well, let this bar be y, okay? And we want to divide this bar into 5 little bits because that's what it means. So if we put 10 in place of the y, this will be 10 divided by 5. Of course, your answer will be 2. If I say substitute y again for when you have the expression 5 over y, you can write 5, and then if you are substituting y with 10, you now have 5 divided by 10. Of course, if you split this bar into 10 little bits, each bar is going to be half for you to get up to the value of 5. Okay, what we've learned so far is substituting into expressions mean you replace the number you replace the letter with the number. Okay, in this instance we are using the bar model. We're still using it as a simple way of thinking about the problem of substitution, but it will get to a point where we'll get really good at it, we no longer need it, or we'll see a problem where it doesn't work all the time. So we have to find another clever way of doing it, which is consistent. Okay, I would like you to have a go at question 1 to 3. So this is question 1 to 2. You can pause the video and do it in 4 minutes. Really taking your time to think about what you're doing. Okay. So assuming you've paused the video and you've worked through the problem, you've really thought about it, here are the answers. So this is the answer for question 1. So for question 1, these are simple substitution. You've been asked substitute h equals 7 into each of these expressions. So if we use the bar model to think about things, 3h means 3 lots of h. So if you put 7 in there in each of the bars, if you then add the bars, you'll have your answer 21. For this one, we have 7 plus 3. So again, if you think about the bar model, it means h and then another bar for 3. So if you replace h with 7, you will have the answer 10. 5h means 5 lots of h in little bars if you were to draw them. So if you put the number 7 in each of them, of course you have 5 lots of 7, so your answer will be 35. So using the bar model, you can see that it's easy to think about some of these simple expressions. And here is the answer for question 2. So question 2, Dexter is substituting y equals to 8 into these expressions. So if y is 8, then we can have 8 plus 3 or 3 plus 8. So he says you will get the same answer for both. Of course, he's right, because remember, we learned even in our previous lesson and when we were doing the retrieval practice that addition and multiplication are commutative. So you can swap things around and you'll still get the same answer. For B, you can see that for saying that you will get the same answer, that's not right, because remember what we've learned, division is not commutative. You can't just swap things around and get the same answer. So y divided by 4 is 8 divided by 4. But if you look at it the other way around, 4 divided by 8 will give you a half. So they're not the same. Okay, for question number 3, Rosie substitutes g equals 12 into the expression 7 minus g. Here is our working out. What has Rosie done wrong? Remember, the expression is 7 minus g. 7 minus 12 should be negative 5, not 5. And here is the answer. You can see it. So Rosie actually did 12 minus 7, not 7 minus 12. Okay, let's look at this. What if we have an expression like this? We can still use the bar model to solve this problem. Of course we can, okay? Because we can represent this to say, okay, for the bar, we have 12 as one bar and q as another bar, because remember, we always add the bars. Then if we replace q, which is what substitute is, with 9.5, we can simply add them. Our answer will be 21.5. But what about this one? This is where the bar model no longer works. So we need to start to use our understanding of algebra. Remember, 3.2 q means 3.2 times q. So remember what you learned. When you write a letter next to a number, it means they're multiplying each other. So we can write this as 3.2 times 9.5, and that gives you 30.4. So when the bar model no longer works, you need to start thinking about using the principles of algebra you have learned. So, is there a mistake here? I want you to have a think. Is there a mistake here? If we substitute k with 14, our answer cannot be 314 for sure, because 3k, I bet you're thinking right now, means 3 times k. So it should be 3 times 14. Okay? And your answer is 42. Okay. I would like you to have a go at the rest of the questions. You can pause the video for 4 minutes and get through these questions, really thinking about all the things we've learned. Okay, assuming you've paused the video and you've really worked through these problems, here are the answers. So this is the answer for question 4. Okay, so for question 4a, you simply substituting the value 16. So p plus 7 would simply be p 16 plus 7. P plus 9.5 will simply be 16 plus 9.5. 6 plus p will simply be 6 plus 16. And then p plus p will simply be 16 plus 16. For b, p minus 3 will simply be 16 minus 3. So by now, you should really know that you can do this really, really well without using the bar model. You just need to follow the principles of algebra. The bar model helps you to understand what is really going on. But once you understand it, you can just substitute the numbers in and you get your results. Okay, so don't forget about this one. P squared, or p to the power 2, means p times p. So it's the same thing as saying 16 times 16. This one here. Okay, this one here. So p means p squared means P times P. So this is the same thing as 16 times 16. Okay. P over 2 means 16 over 2, which is 8. Okay. And then square root means what would you multiply by itself, thinking about your simple numbers, to give you 16. Of course, that number is 4. Okay. And this is the answer for question 5. Okay. So for question 5, you were asked match the expressions that will be equal when y is equal to 5. Okay. So when y is equal to 5, the expressions that will be equal will be these ones. Okay. So remember, y plus 5 is commutative with 5 plus y. Okay. I'll pause for you to have a think about this. Just have a look. Or you can pause the video. Let me rub this off. Okay. The next one is which cards will have the greatest value when y is 1? Of course, the card y plus 5 or 5 plus y will have the greatest value. Okay. Here is the answer to C. 5C. You ask y minus 5 and 5 minus y will always give the same answer for every value of y. Of course, that's not true. You can just use a simple example to show that's not true. If we put y equals 1, y minus 5 will be negative 4 and 5 minus y will be 4. Negative 4 is not equal to 4. You can see it here. So they won't give you the same answer. And another reason, don't forget, subtraction is not commutative. Which of the expressions will always be equal, whatever the value of y? For question D, of course, it's 5 plus y and y plus 5. Okay? Remember, addition and multiplication are commutative. You can swap things around and you will get the same answer. Okay, that brings us to the end of our lesson. So what have we learned so far? In substituting into algebraic expressions, you must remember that you can use the bar model to help you understand really simple expressions. But once you get past that, you can simply just substitute, replace the numbers, replace the letters with the numbers, remembering that if you have an expression, for example, 5a, 5a means 5 times a. So if I ask you to substitute, for example, 6 for a, then it doesn't mean 5a is 56. It means 5a is 5 times 6. Okay, so these are some of the things we've learned in substituting into expressions. Until next time, take care and bye-bye.